today's video, here is a nice problem that was checked just by viewer. Here is the following information. Find all x, y as integers, satisfy this following equation. We get x cubed plus x squared plus x plus number 1 equals 2003 to the y as a power. Okay, now let's go through the solution to see what's given us. Okay, so we are going to, in the beginning, just we are going to check the obvious solution. Let's check y equals 0. Okay, so for all y is super equal to 0, y equals 0. Okay, so thus it's more simple, x must be equal 0, because replacing x with 0 I get number 1 which equals 1, which is okay. So get the first obvious solution, x equals 0 and y equals 0 as an integer. Now let's check if y is super equal to 1. Okay, so I'm simply going to factor out this one. So I get 4 terms here. I'm going to take every 2 terms together to make x plus number 1 as a common factor. What we are going to be ended, we are going to be ended with x plus 1 factor x squared plus number 1 which equals 2003 all is raised to the y as a power. Okay, now since 2003 is a prime, so we have a factorization prime here, which means each of the term here is going to be a power of. And also if you take a look at this equation, x must be even, because we get this one is odd, which means the left hand side of this equation must be odd. Array number 1 here, which means these 3 terms which is involving x must be even. Even plus even is going to give us even. X cannot be odd. Okay, so now x is a even. If x is a even, which means this one is a odd, this one is a odd. So I will have a nice equation system here. So I get x plus number 1 is going to be written as 2003 or to the a. The other one I get x squared plus number 1 which equals 2003 to the b. Where is b? Strictly super than a. Also b plus a equals y. Okay, now the best way to solve this one, I'm simply going to take the difference between this equation and this equation. So I will have the following. I get x squared plus 1 minus x minus number 1. I get number 1 cancelled out. I will be left with x factor x minus number 1 which equals 2003 to the b minus 2003 to the a. Since this term is smaller than this term, I'm going to take it as a common factor. So we get 2003 all to the a factor 2003 to the b minus a minus number 1, like this. So if you take a look at the left hand side of the equation, so we get GCD of these 2 terms, GCD of x and x minus number 1 equals 1, because they differ by number 1. Okay, also this one, GCD of this one equals 1, because this term divides this one, but this term cannot divide number 1 except if a equals 0. Okay, so now since this one is a odd, because x was even, this x must be even, so which means x minus number 1 is going to take 2003 to the a. So this one is Italian as x minus number 1 is going to take 2003 to the a. The other one, x is going to take 2003 to the b minus a minus number 1, since x is a even. Okay, now solving this equation, I'm going to replace x in the first equation with this quantity. Okay, so I get here x will be replaced with 2003 to the b minus a minus number 1 minus another extra minus number 1 which equals 2003 to the a. So moving over this number 2, because I get minus number 1 it becomes minus 2. I'm going to move it over to the other side of the equation, then move over back to the left, 2003 to the a next to this term. So I get here 2003 to to the b minus a minus 2003 to the a, which equals number 2. Okay, then I'm going to take 2003 to the a as a common factor because this term is bigger than this term. So I will have 2003 to the a factor 2003 to the b minus a minus another a, which is minus 2a. Okay, minus 2a minus number 1, which equals number 2. Okay, I have extracted a nice equation here, so it's more simple to solve now this equation. Since 2003 to the a is odd, is going to take number 1. In the other word, a must be equal 0. This one is going to take number 2. Okay, so I get here a equals 0, then replacing a with 0 into this one, so I get 2003 to the b minus 1 equals 2. So moving over number 1 to the right, I get 2003 to the b, which equals number 3. It's impossible to be like this. This is clearly, it's a contradiction. It's impossible because never ever you see 2003 to the b, which equals 3. Okay, so which means you have no solutions above y equals 1. The only solution that we get, y equals 0 as a solution. Okay, you might say if y is negative, if y is negative, this one becomes not integer. Okay, which means the left hand side of the equation is not integer as well, which means you have no solutions over negative integers. Okay, so I have done with this problem. Thank you. Bye.